Hi there, and thanks for tuning in. I'm Yvan Fafchamps from UbiOps, and today I'm joined by Leo de Vries from Bytesnet. Today we're going to be exploring the best ways to support AI workloads. We're going to explore this by taking a look at the challenges involved in hosting and serving AI workloads, and then we're going to go into the best practices and solutions to make sure your models have a strong support structure to keep them up and running whenever you need them. So let's get down to business. Leo, thank you so much for joining me. Why don't we start off with a bit of an introduction? So would you like to tell us a little bit about yourself?
Well, for those of you who do not know the Netherlands, I'm living in a small place near Groningen, which is in the northern part of the Netherlands. We, which includes my wife and two daughters, moved over there from far away from the big cities. We used to live near Rotterdam and Amsterdam. And we were a bit fed up with all the traffic jam, the air pollutions and the noises there. So I'm living in a very small and quiet green community here. And we realized over the years that it's important in life to stay healthy, to have fun in your work, be innovative, and do something for the world. As you all can see, I have a few gray hairs left behind, so I'm not in the beginning of my career anymore. When I look back on my career, when I left high school looking for a job, there was not much work around, which had to do with mechanical engineering, which is my core study. Afterwards, I studied business informatics and I went to the university in Groningen to get my master in business administration. At that time, I was already interested in computers, and I joined a small company, which got me educated in COBOL, RPG, IMS, big IBM environments. And later on, I moved over to the IBM AS400, which is now called the I-Series. And during my career, a few large IT companies came on my path, and in the end, I joined CMG, which is currently known as CGI, where I became a managing director for several verticals like telecom, insurances, and energy. And after that, I had a few management roles with large companies. And as from 2011, I started my own company, and I've been working for that ever since. And I joined Bytesnet about 6 years ago when they started up shop for a new HPC as a service delivery, where I'm the manager from.
Great. Thank you so much for that comprehensive background. You mentioned Bytesnet at the end there. So for those unfamiliar, what does Bytesnet do?
Bytesnet originates from the early days of the Internet Exchange. And the owner then, which is still the current owner, Peter de Jong, he set up Groningen Internet Exchange and Rotterdam Internet Exchange. And soon after that, the demand started to rise for data center and co-locations. So Bytesnet set up a data center in Rotterdam. And from 2018, Bytesnet built a state-of-the-art new data center in Groningen in the northern parts, where our HPC Cloud services are delivered from. It's a brand new data center. It's green, it's sustainable, it doesn't use water, it has a very low PUE, and it returns the generated heat back to the community. And we offer our HPC services, including NVIDIA A100, managed Kubernetes, managed firewall, DDL Lustre storage, Ceph, and everything we deliver there from the data center in Groningen. In Groningen, we offer, next to the straightforward co-location services, which are predominantly air-cooled at the moment, the possibility to use any form of liquid cooling. So backdoor cooling, on-chip cooling, pot cooling with oil, cassette cooling, you name it, and we can handle it in large volumes. And next to that, we still can deliver enough power to the data center, which is very difficult in many other parts of the Netherlands. So that's Bytesnet in a nutshell.
So what is it that you specifically do at Bytesnet?
Well, I'm the manager of the business line HPC as a service, which delivers HPC services to customers, mainly around CPUs, big memory CPUs, NVIDIA A100, storage solutions, and networking facilities for these customers. So I have a team in Rotterdam and a team in Groningen, which deliver it on an OpenStack platform that we have. And we do that with a lot of fun for these customers, mainly customers in research, hospitals, processing a lot of data, want to be reliable services from us. So we offer everything as a service to them with flexible price models, etc.
Right. So your main kind of bread and butter there is high performance computing, right? Could you give just a kind of quick definition of high performance computing?
Sure. High performance computing is a technology that leverages clusters of powerful processors to large scale multi-dimensional data sets and process these, and which can solve big problems at extremely high speeds. It works by parallel computing mainly, where multiple tasks were executed on the same multi-computer service and processes. And it's used on an HPC cluster, which consists of nodes and servers, using all these CPUs or GPUs in those days to make it suitable for big mathematical calculations, machine learning models, and other graphic-intensive tasks. And next to that, you also need, of course, high speed, high throughput, low latency, storage, memory, anything else necessary for the performance of these nodes. Otherwise, it will not work. So that's what we also deliver.
So high performance computing is something that's going to be typically fitting in somewhere into that machine learning operations, that MLOps sort of space. So for you, what does MLOps represent for you?
Well, I've been in the old days when DevOps was brought to light. So when I see MLOps, I see almost the same thing. And I would refer to it as a set of practices that aims to automate and simplify machine learning workloads and deployment. I think it combines machine learning application developments, the dev side of the part, with machine learning deployment operations, the ops part, and it unifies these two processes and is designed to automate and standardize processing across the machine learning lifecycle, which includes model development, testing, integration, release management, and infrastructure management.
Within that kind of space, where does Bytesnet fit as a sort of infrastructure as a service provider?
Well, I think there are many organizations who have large quota of data science working with environments that are struggling with MLOps. Most often, these teams will patch together all elements using different tools and services and try to manage them all, which is really hard and very difficult to see the bigger picture. With Bytesnet offering HPC as a service, we felt an excellent piece of tooling could streamline both the entire MLOps and AI infrastructure experience through a single control plane would be a solution. So we ran into UbiOps, and it was a perfect fit from day on. They are the middle layer on top of our infrastructure platform, and they take care of everything that's needed to let the data scientists do their work. So it basically encompasses all the processes required to successfully take an AI machine learning model to market and make it sure it doesn't break. And you can do training with it, monitoring, evaluating, building pipelines, and you can manage it, of course, in access control, security. So UbiOps is the middleman, and Bytesnet gets the AI infrastructure beneath it.
I could not have put that better myself. Thank you very much for that explanation. I would add just a little bit about some of the features involved. So UbiOps has a lot of powerful MLOps features that are just really easy to use. So pipelines tends to be our most recognized one. So it allows users to chain together multiple objects like deployments or even other pipelines, as well as standardizing workflows with a selection of predefined functions. They're a great way to optimize your use of computing resources, reduce your costs, and work in a more manageable, modular way, whether you're working through an IDE or through the visual interface that we have within the web app. So why would you say is HPC Cloud HPC important for running AI and ML models?
Well, there are a number of reasons which make it quite important, I think. The first one I would like to mention is the scalability. Cloud HPC provides the flexibility to scale resources up and down based on the demand, which is particularly useful for managing fluctuations when needed. It's very cost effective, I think. By accessing it as a service in the cloud, organizations can avoid to do the investment by themselves and purchase everything and maintaining the environment and getting people in who can manage it, of course. The cluster environment has a resource optimization in it, so it can distribute workloads efficiently across CPUs and GPUs. Sometimes for like autonomous vehicles and medical diagnostics, real-time processing is necessary, or near real-time is necessary. That makes it possible on the HPC platform that we deliver. And of course, HPC system can leverage parallel processing to perform complex computations at very high speed, which is essential for training the models and processing big data. And on top of that, when you use it in combination with UbiOps, you can reduce your complexity. You can manage your system for one control plane, which makes it quite easy for everything to handle. And in the end, you get, I think, access to the latest technologies. Cloud providers continually upgrade their environment to offering the latest in AI and ML technologies, ensuring that the users have everything they need for their frameworks and to do their work.
How can a business actually that wants to run their own AI and ML models, how can they access cloud HPC? Do they tend to do that directly or through a software as a service provider, or how does that tend to happen?
Well, HPC solutions can be deployed on-premise, in the edge, or in the cloud. It's sometimes referred to as HPC as a service. That's what we also use. It offers the scalability and affordability way for companies to leverage HPC. When you look at the most common ways on using it, there's a hybrid cloud approach, which is very popular in these days. Then you can use the on-prem environment, the public cloud and the private cloud in combination. And using that on the UbiOps platform, it's one bunch of resources that you can manage. You don't see where it's coming from, so that's quite easy to do. You can do it directly, of course, via the cloud providers. These companies purchase their HPC environments and put them in service for this customer, and you can manage it. You can adapt the configuration if you want it. You can scale it. You can maintain it. And there also are a few providers that have managed services like we do, and they offer more on top of the HPC platform, like set up and manage things for them, the firewalls if needed, the backups if needed, the storage environment, connectivity. So there are several ways on using this environment.
So what would you say are the pros and cons of sourcing compute from a cloud HPC provider through an orchestration layer?
Well, when you look at the cloud providing part of it, the scalability is enormous. I think you can immediately scale up or scale down if you want. You can match your varying workload if needed. There's a lot of flexibility in there. You can use different type of instances. You can use different operating systems. Different programming languages. You can get support if needed, and you can even use your own custom configuration if you want. It's very easy to use. There's a simple onboarding process. There's mostly a very transparent pricing model. You can pay per use if you want that model. You can start very quickly. And there are specialized offers most of the time in the time frame that you're using. And some of the workloads can be run on GPU to get a better performance. And also we'll take care of the security and encryption if needed. The cons, there are a few cons, I think. When you look at the public cloud mainly, there is data egress. Transferring data into the cloud is not costly. There's no problem mostly, but once you get it out, it will cost time and money for that. So especially for large data sets, that's difficult, I think. The costs are not so much in control, I think. When you look at the environment that we have with UbiOps, you get a fast grip on cost control. It's especially good for short-term and sporadic use. Otherwise, you pay a lot of money, I think. And sometimes there's difficulty that you run into with licensing. If you have a licensing on your on-prem and you want to use it in a provider way, well, you need to tick some boxes to get that up and running. When you use your orchestration layer, it's a hybrid environment with a combination of things. When you use on-prem or cloud or public cloud or private cloud, the resources allocation is quite simple. The data handling is quite easy to do. You can even integrate it with your own infrastructure, so the orchestration layer can facilitate the better integration with it. Sometimes it's a little bit more complex because you need to implement and manage an orchestration layer, but when you have good software, that's no problem, I think. And the maintenance you have to do by yourself. There's some additional overhead for maintenance if you're not well equipped with an orchestration layer. And you need to ensure compatibility with cloud and on-premise systems, so you need a mixture of that. And sometimes there are also network consideration, of course. An adequate network with connectivity and bandwidth needs to be there between the cloud and between on-premise and to make it run smoothly.
So what would you say are the advantages and disadvantages of building on-premise versus opting for a cloud service?
Well, most parties that have on-premise systems do that because they want to have control. That's an old saying. When it's in your own data center, in your own location, you have control on it. You can do what you want with it. It's important, I think, for companies that have very sensitive information. We have a few companies in the Netherlands that only use on-premise, and they're very scared in moving over to a private cloud. They don't go to a public cloud. They want a customized environment, a specific solution tailored to meet their specific needs. They can get the performance they want, but they need a large investment for that, of course. And disaster recovery needs to be taken care of on the premise systems. You can have better control of that when it's crucial for an event of a disaster. But the other side, the disadvantages of that, the costs are extremely. If you want to set up your own environment, keep it on, maintenance costs, hardware repair, software, new hardware you're going to get in is very difficult. It's not that scalable on premise, so it's very easy to do that in the cloud. And there's a little bit lack of flexibility. It's an environment that's there, it's made for you, but the flexibility that cloud services offer, they do not get it on the right scale down on your own environment, I think. So that's one of the advantages of cloud services. I think it's very cost effective because you can use a pay-as-you-go model. You can leave costs which are not interesting for you behind. You do not have to invest for yourself, so it moves over from capex to opex cost. It's very scalable, and the maintenance is done by the provider, so you don't have to do anything about it. Access is quite easy. So these are the advantages, I think, of the cloud services. Some of the disadvantages there you can mention. Sometimes the latency is a problem if there's a bad quality of internet connection between the location. There are still security concerns, of course. Cloud providers offer robust security measures, but still some concerns about the data breaches and unauthorized access and data being in countries that you don't want it. And of course, you're relying on a third-party provider for your services, and that's also sometimes difficult for people. I think when you look at the mainstream now is a hybrid solution where there is some hardware being on-prem, but it's not much anymore. Private cloud provider which helps you, and the public cloud provider in a mixture where you can leave your data, which is not that important in the public cloud, and what's important for you, you do it in the private cloud.
Yeah, you definitely see a lot of businesses opting for that kind of hybrid setup nowadays, where you can use your own resources to cover your basic needs, but if there's some kind of spike or if there's a particular circumstance where you just need a boost, then you can just scale up to the cloud. So okay, so I think we've seen the sort of challenges that are involved in running and serving your AI and ML models. So let's move on to the solutions. So how to solve those. So why don't we start with like what is the BytesNet and UbiOps offering? Like what are we offering to people together?
Well, I started BytesNet in my company. We offer an environment for customers, either bare metal or VMs based, mostly Linux based in that environment, with on top of that NVIDIA A100 GPUs, which are quite often used. We have come big memory service, storage service next to that, and connectivity. And on top of that, we'll place the UbiOps MLOps platform, which gives the customers a control plane where all the resources are being managed from, and the billing is done from UbiOps. So you have a fully integrated solution for customers using our infrastructure and MLOps environment and doing their jobs on it, on their ML jobs and AI loads running on that in the pipelines. So it's quite an interesting opportunity. So we're offering that both to the market.
Now, to get to the central question of this interview, how does this lead to better support for AI workloads?
Well, the combinations, I think, enables the automations of the stages of the machine learning pipelines. So you can make it repeatable, consistently, and scalability. That's very, very important, I think. This also includes the pre-processing, the model training, the validation of the deployment. Automatic testing can help you discover problems very, very early and fast and fix them. Automation is more efficient with the infrastructure. When you can make it reproducible and you can make it consistently deployed over various environments, different environments. And also it's very important that for these customers that it's run on a fully sustainable infrastructure at BytesNet in a data center which has all the necessary ISO and NEN certificates. To do this in a secure way, fully under the Dutch law. So it's a very nice combination for many participant in Western Europe, I would say.
Yeah, I will back you on that.
Yeah.
So what are the advantages of accessing Bytesnet high performance computing capabilities via a turnkey software as a service platform like UbiOps?
I think for the customers that need it, it's a one-stop shop. They either call Bytesnet or call UbiOps, and they get the same platform delivered to them in a way that's easy to use, easy to start with. We can get it instantly ready for them. We can combine it for on-prem, public cloud, and private cloud combinations. So for the end users, the data scientists that are using this environment, it's just an environment with resources they need to handle and need to take care of it, and it's being taken care of by one control plane who does everything for them. So they can run their pipelines, do anything with it, and make it a very efficient way of delivering the jobs they need to deliver with it.
So tying this back to what we talked about a little bit before about on-premise versus opting for cloud services and some of the advantages and disadvantages there. One of the things you mentioned was security and compliance. So how do customers' data and intellectual property remain secure while still using this kind of UbiOps Bytesnet collaboration?
Yep. Well, we have a few things in place at Bytesnet. We have all the necessary ISO and NEN certifications to hold and process financial and patient-related data. We have a lot of customers who are hospitals, and they keep their electronic patient dossiers at our location. Next to that, on our infrastructure, there's a VLAN structure set up for separate tenants, so you cannot see any data of each other. And the data can, of course, be encrypted at rest and on flight, so there's also not a problem there. So we are very well equipped to keep the data and the IP remain secure for our customers.
Leo, that's actually pretty much all the questions I had for you today. This has been so informative. I actually have one last question that I'd like to ask before we close our session. If you had to give one single piece of advice to a data science team out there, what would it be?
Well, I think I would move over to the ethicals and the responsibility side. So ethical, be responsible for what you do. And from Bytesnet, remember one thing, that data is gravity. It all comes down to infra in the end. That's what I would like to offer them.
That's fantastic. Very nicely wrapped up and also very, ethically responsible. I like that. Leo, I would like to thank you again for joining me today and for sharing your insights on the best ways to support AI workloads. I learned a lot. I'm sure our viewers did too. Thank you so much.
Thanks so much, Yvan, for having me. Have a nice day.
Thanks for watching. Make sure you subscribe to our YouTube channel so you don't miss out on the next interview or webinar, and subscribe to our newsletter for more content. Or if you have any questions of your own about today's topic, drop a comment below or join our Slack community and ask us there. You can find links for all of those things in the description below the video or on our website, ubiops.com. If you'd like to learn a bit more about UbiOps, you can always head over to our website. We have guides, tutorials, use cases, everything you need to know more about the platform, as well as best practices to get you deploying AI like a pro. Once again, I'm Yvan Fafchamps from UbiOps. Thank you so much for joining. We'll see you next time.